So before you go on, Claude, I think that there's a really interesting part of that question, the myth of the deduplication hurts performance. A lot of folks are really leery about turning deduplication off because they feel it's going to really hit the CPU hard and it's going to really degrade performance. And I think it goes back to what the message we keep trying to say is that NetApp does it differently. Where other vendors have a certain thing that they do. We're one of the few vendors, I guess, that actually wants you to use less storage, which is kind of a weird thing. So our deduplication is post-process. It's not inline. It actually uses, it doesn't use the CPU, during your hot spots or anything like that. You can actually set it when you want to, and the deduplication aware, or I should say the cache aware with the deduplication. So I think it again boils back down to NetApp does things differently, and when you try and compare NetApp to another storage vendor, you kind of have to step back and say, we do things differently.
Mm-hmm. Any questions from the audience on this topic?
Here we go.
Yeah, we see a lot of what I would consider to be mix. We've talked about that, Nick, right? Where you have a lot of XenApp-based desktops as well as VDI-based desktops. And then, of course, we have, obviously a different IOPS footprint on that sort of thing and so on and so forth. My question is, when you start to see this mix in a given virtualization silo going off to a NetApp backend, for example, how does this mix of desktop footprint affect the storage controller and the performance there and so on and so forth, the amounts of RAM that are needed there?
So you guys want to talk about the workloads and the profiles of the workloads?
Yeah, and that's what it comes down to is based on the type of workload that it is. So XenApp, being more, it depends. We're using PVS, but let's say we are. It's more reads. It's still. It might not be 90-10 like we've talked about with Zen Desktop, but maybe it's like 65-35 or something, right? Right to read ratio with XenApp. So we design the storage accordingly. Right. We carve out the LUNs or the flex vols, right, on the NetApp. We can even do special things like carve up cache or dedicate flash cards or PAM cards to this and not that. And then with Zen Desktop, we look at the I/O characteristics of the workload and we size it appropriately on the array. And so that might be a different set of LUNs and flex vols and separate cache allocated to them.
Two separate designs for the storage, basically, to allocate to the two separate delivery methodologies.
Yeah, and that's what I was kind of getting at in the last question was, XenApp, that resource pool is going to have some SR attached to it. That might be better off with, RAID DP or RAID 5, right? Something that's better for maybe reads. Yeah, but
thank you.
Versus, I was just going to say to finish the thought, versus Zen Desktop, separate resource pool or cluster attached to that, separate SR, right, with different RAID characteristics, right? Yep. So you just got to be smart about the workload, and the I/O characteristics of that workload.
So I would chime in here. So one of the things that we've seen over the last several years, particularly as the virtual infrastructure has matured and we've seen that the desktop space kind of grow along with it, has been, particularly in desktop sizing, right? It always seems like we size for a data and a sizing that tends to be very different after it's in production, right? It seems like the customers sometimes historically haven't been able to capture the correct profile of their workforce before deploying a configuration. And so one of the nice things about a NetApp config actually collects a bunch of the data points that have been shared here on stage, which is we don't provide, in almost every case, in the majority of cases, we don't provide access that's bound to physical constraints. Your physical devices, your CPU, your memory, your disk drives, they all have finite performance capabilities, right? A certain number of IOPS, a certain amount of CPU cycles, right? A certain amount of memory capacity. Everything in the NetApp arrays is designed around pools, and so we make RAID groups and we RAID protect the entire array. We then make storage in the construct of a flexible volume, and it's just a software limiter, right? It's dynamically adjusted. It can be dynamically moved between different disk drive types, moved between controllers. Same thing with the memory and all the memory settings that Nick was sharing, which we can do prioritization of workloads. These are all software assignments. And so the benefit of this is you get 2 workloads, as you explained. You did all your sizing. Now you're looking at the customers in production, and the customer's saying, I've got a pain point over here, but I've got excess resources over there. It's a software throttle and a software change in many cases versus saying, man, I did a RAID 5 here and a RAID 10 there, and I got to start migrating data, right? I don't have hardware boundaries to get around. I've got software limits to just start adjusting. Now, don't get me wrong, if you overrun the capability of the hardware, you got to throw more hardware at the problem, but with a lot of flexibility when you're all just software driven.
Yeah, and we're missing the part too about the storage protocol, right? Is it NFS as a file-based protocol, or is it a block-based protocol like Fiber Channel or iSCSI? Because that'll change things too. If we have a fiber channel for the for the protocol, we might size those LUNs or FlexVols differently than we are using NFS, and also for a different workload like XenApp.
Speaking of NFS,
So before you go on, we actually have a sizer that you probably, as NetApp partners can probably use. Before we actually have, what I recommend strongly is before sales actually says, okay, this is the controller that I want the customer to use, I say, have you done some sort of an assessment with them? Have you used a Liquidware Labs or a Lakeside type software, installed it in their environment? Have you gotten real good data? Because unfortunately, customers, they try, but unfortunately they don't give you the best data. We all know it, that they give you information that's probably not true, not to their detriment, or not because they're lying. It's just because it's the fact. They just don't necessarily know what's going on in their environment. So what I say before, a lot of times I'll get, the workload's 10 IOPS. Tell me what storage to buy. I go, that's not enough information for me. I say, go install this tool, go get some really good data points, then we can talk. And we actually have reports that feed directly into our sizer, which go, you feed all the information in Bing, it gives you the appropriate size storage. So that's my recommendation, is before you even say, look at what the customer has. And a lot of times they go, well, I haven't virtualized anything. Like, that's fine. Look at what they're doing in their physical environment. Get some data points.
We're guilty of this too, though. I'll take some blame here. We say like, oh, this Windows 7 VM takes 10 or 15 average IOPS per VM. All IOPS are not created equal. That's what's the block size, right? It's throughput is like the best measure. So what's the block size? Is it random? Is it sequential? Is it a read or a write IOP? They're all different. So until you tell me the block size and what type of those, random read, right, what sequential, I really don't know. So it's all about throughput, which Alex will probably tell me.
Yeah.
Put a mic on it.
Put a mic on him. That's what I was getting at. I threw that in there for you. So PVS, the little SCSI driver, right? It limits it from, it's usually going to be 4K to 32K, right? That's important for us to understand as storage architects.
Extremely.
I use that term really loosely.
So you could have a desktop that might cost
Do we have
$20
a
or
question
a
in the back
desktop that
right
costs
there?
$100+.
Yeah.
Question in the back right?
Yeah. Can
Well,
you
we're
talk
good. Oh, go ahead.
Can you talk a little bit about NetApp's flash pool as compared to EMC's fast?
Can you speak a little louder?
so the question was, can I compare NetApp's flash pools to EMC's fast? Is that what you said? Okay. So I'll actually elaborate on that a bit. So EMC has a tiering technology called fast, and it's very easy to understand. They basically represent different types of disk drives between a SATA drive that's deep and cheap and slow, a moderate performing drive like a SAS drive, and then show you solid state drives. And they have this software technology called FAST that says it will tier or move your data to the appropriate disk type technology based on the access of the data sitting on that drive. So in other words, if you've got data and it's sitting on SAS drives, but it should be on solid state, it will promote up that data set from SAS drives to solid state. That tiering mechanism has a couple of issues with it. One is the block size of the tiering is different based on the storage controller platform that you buy in terms of the chunk sizes or the data set sizes that it will tier. So the problem with that is if you design an application based on, say, a VNX platform, but you provision it in production on a VMAX platform, you get different tiering characteristics with your workload, and you have to be aware of that, and they can be detrimental. The second is fast is retroactive. In other words, if you get into a performance situation, it does not dynamically provide you any type of, it does not have a means to dynamically start accelerating your workload and tiering it, it kicks in retroactively after you've weathered the storm, after you've had
might wait
users
a day.
complain.
Yeah.
Then when a peak of low load, it'll then start to migrate your data in hopes that you'll experience that workload again. Now in a desktop space, you could say, I provisioned it in one spot, that we had a bad day, it promotes at night, maybe I just have one day, because it's going to be a repeatable type of IO pattern within the workload. But on some other workload, when you're just in kind of general virtualization at large, and you have, particularly if you're a cloud, right, building a private or public cloud, where you really, as a storage admin, have no idea what workload's being put on your array, you have no idea whether tiering will ever help you because it cannot kick in during the time of peak load. What we've done is implement a caching mechanism between flash cache, flash pools, in the array where our whole goal is it's tiering, but it's all based on dynamic tiering. So in other words, we start to address a spike in a certain workload or flexible volume, and the system starts to shift prioritization of caching for that workload. Now we can non-destructively move the entire workload to a different set of disk drives, but our model is to always demote. In other words, you deployed something on SAS drives, the system management tools will tell you over time, over history, that data set's got a low IO load. It'd probably be better served on SATA, and we'll let you non-destructively demote that data down to a disk because it's more cost-effective or more greater cost benefit to the customer because we're very confident in our caching mechanism to dynamically promote the resources to serve a workload. Now, that doesn't mean you couldn't get an environment that just should be on all SSD, something that's 100% random and has no cache capabilities to it, but those are edge case workloads. Those aren't, those aren't the unexpected spikes. Our platforms are designed to be resilient in the face of an unexpected spike. Anyone?
Guys, I'm going to move on to the next myth just for time purposes.
Sure.